Okay, here we are going to prove that the three altitudes of this particular triangle are concurrent, specifically at the point 0, 4. First, altitudes. What are they? Well, an altitude of a triangle is the height of the triangle. Like an airplane flies at an altitude, it's how high up it is. It's the height of the triangle. And there's three of them, depending on what you call the base of the triangle. So, in this triangle, if CA is the base, then BF is the height. Or, if I turn it this way, if BC is the base, then AE is the height. Or if I turn it around this way, if AB is the base, then CD is the height. Now, the important thing about the altitude is that it goes from a vertex, right, to the opposite side. Well, it travels from the vertex toward the opposite side, and it's perpendicular to the opposite side, but it doesn't always touch it. So, for example, this triangle right here, here's an example. All right, that triangle right there has an altitude that's out here. It's perpendicular to the base, but it's not. It doesn't actually touch the base of the triangle, but it's still the height. That's how tall the triangle is. All right. So our goal here is to write equations for these three lines, and then show where that they all intersect at the same place. So let's start with AE. So to find the equation for AE, first we have to know what the slope of BC is. So let's write this down. So we have slope BC is, if we look here, 1 over 2. And we could actually do the calculation, but I'm gonna cut us a little bit of slack here. We could go, well, let's go ahead and do it. 8 minus 0 over 0 minus negative 4, which is 2, works out to 2. All right, that means that the slope of AE is going to be the negative reciprocal of that, which will be negative 1/2. All right, negative reciprocal. So the equation y equals mx minus h plus k. Slope is negative 1/2. X minus, well, the point we have is 8 plus 0. So y equals negative 1/2 x, let's see, plus 4. So there's our equation for AE. Yeah. Now let's do our equation for CD. So first, we've got slope of BA, which is, that's BA, is, let's see, 8 minus 0. Oh, I keep writing that. 8 minus 0 over 0 minus 8, which is negative 1. So the slope of CD should be a positive 1. You can think of this as negative 1 over 1, flip it upside down, you still have negative 1 over 1, and change the sign, you get a positive 1 over 1. So our equation is y equals, hello. Hey, how's it going?
Fine, how are you?
Oh, not too bad. Okay, so where we're here, it's m x minus h plus k, where m is the slope, hk is a point. So y equals, our slope is 1, and x minus our point, we're doing this one, so it's negative 4, and plus k, which is 0. That's the y-coordinate of our point. All right, so let's see. Well, this is a pretty easy one, actually. So this becomes the 1, pretty much distributes itself away. So x, and then minus a negative 4 is plus 4, and plus 0 is nothing. So our equation is y equals x plus 4. And the last equation, well, because it's just a perfectly vertical line for BF, right, that's just going to be x equals 0, right? Because it's actually the y-axis. So at this point, every point on this line is an x-coordinate of 0, so it's x equals 0. All right, so now we just have to put these two equations together and figure out what their point of intersection is, and then we will check to see that that is also on this line over here. I mean, we could find a point of intersection of these two, these two, these two, and show that it's the same point. But it'd be easier just to find these two and show that point is actually on this line, which will be easy because it better have a y coordinate, an x coordinate of 0. So let's see, let's find the intersection. So we've got negative 1/2 x plus 4 equal to x plus 4. So let's see, I'm going to add 1/2 x to each side, and I will take 4 away from each side. Oh, this is going to be easy because look, when I take 4 away from each side, I get 0. So it really doesn't matter what the coefficient of x is, but we'll find it. It's 3/2 x, and divide both sides by 3/2. Well, 0 divided by 3/2 is 0. So x equals 0, right? Just like over here. So now we've got to plug that back into one of these equations. Y equals x plus 4. Plug 0 in, 0 plus 4, and we get y equals 4. There we go. So our point of intersection is 0, 4, which we could, if this were a more complicated equation, we could plug the 0 we have for x into this equation here. We could figure out if it outputs a 4, but we don't have to really worry about it because, well, x is 0, and it's on that line. Okay. Again, the word for this, by the way, is concurrent. When 3 lines meet at the same point, they are concurrent. And also, this point here is known as the orthocenter. The orthocenter, the place where the 3 altitudes meet.